Assalamu alaikum, welcome back to my channel. One of my subscriber requests me to do a substation drawing. So substation drawing is a big subject. So we have to know some certain things before doing a substation drawing. So first we have to understand the electrical network. Okay. So let's make one box RAC. So let's type text. One click here, one click here. So we put this one PG. So I'm calling this one PG, meaning this is power generating. You can say or electrical generating, anything like EG. Okay, let's say EG, electrical generation. So this electrical generating, country to country will be different. Some country generate electricity from river. So river force, not from river. They use river force. Some countries they generate electricity from uh, what is that called? Uh, Using atom nuclear system. Okay, some developed country they use. And there is some more electrical generating system like a solar system, wind system, too many things. Anyhow, so let's consider this one electrical generating place. Whatever source, we don't have to worry about that one. So from here, the generated electrical will be transferred to another place called step up. We can call SU. Then it will transfer to another place. From here, it will come step down. Okay. So let's draw wire. Oh, sorry, cable. These are the cables. Then from here, it will go to another panel called HV panel, or we can call this one LV panel, LV. Okay. So from here, it will go to MV. So I will tell you again from the beginning, you will understand very well. So from here, it will go to SMDB. So from here, it will go to DB. So from here, it will go to electrical source. ES. What electrical source can be? Sockets, lights, any electrical equipment. So we can do electrical equipment and wiring accessories. So we will call WE. So wiring accessories meaning light, sockets, anything, the last part. So what happened? The electrical generation plate, this one, normally they will generate electric 11 kilovolt ampere. We can kilovolt will consider kilo, not kVA, kV. Okay. So this one normally will be very distance place. Somewhere very distance place. So very distance place. Okay. Very distance place. Very distant distance MCV, I think. Very long distance, I think. I have to make long distance. So this one, particularly this TXT2MX, so you can make like this. Okay, this one. So they will have one substation. So this substation is different. What they will do, that this substation will just increase the volt from 11 kV to 66 kV. Okay. Then it will transfer to this substation. This substation, what it will do, it will convert again 11 kV to, let's make it this 66 kV to again 11 kV. Okay. So from here, this panel will convert this one into 440 volt or 415, whatever, depend on as per the country standard. Okay. Sorry. V. Okay. So this will be continue. Copy and continue. Uh, and this one will be again 240 or 215 or 230, anything as per the country standard. Okay, let's move this one. This is the networking system. So power will generate, they will generate 11 kV. Some areas, some depend on the country, they can be go higher and lower, it's depend. And this is step up process, can be one time or two time, three time, it's depend, and step down also same. But this is our general idea. So 11 kV to 66 kV, why they are step upping the voltage? Because when you want to travel when you want to travel your current, if you travel from 11 kV, when it is reaching to this level, you will have voltage drop. So you will not get 11. So you will go lesser than 11. So once you step up to 66 kV, then when you can step down to 11 kV again. So this is one reason. Another reason, this is another main reason. You can ask why if we reach 10 kV, still we can step up. Same process what we are doing here. Yes, it's correct, but it's happening here. Uh, Another reason, when you increase the volt, the ampere will be lower. When the ampere will lower, the cable size will be small. Uh, if voltage is high, sorry, voltage is low, the ampere will be increased. When the ampere increase, the cable size will be bigger. So this is the main reason they step up this one. So when you are going in the street, let's go to the electrical tower. And you will see very small, this one, small cable. This is high voltage cable. Okay. So this high voltage cable, this cable small because of reason this volt is high. If volt is low, the ampere will be increased. When the ampere increase, the cable size will be bigger. So this is the main reason. Okay. So we call this part REC. This part up to here HV, high voltage part. Okay. So this is what happened here. So when the LV panel come, this LV panel, before this LV panel, I have to do another this transformer. Actually, this is the LV. and there will be a transformer which will convert to the 11 kV to we will put TX to 440. So here you will receive 1 kVA and it will convert to 440. So this transformer available here also. The step up, step down, all is this is transformer play the role. Okay, this is different type of transformers. So this is the electrical network. So our part, when we are doing the substation work, we have to do from starting here up to, can be here or up to here. It's depend on the design. Okay. So you see here, there's a three part. 1, 2, 3. Okay. This is three part. So this one can be included here also. You can put somewhere here, but let's go with this three part. That what we do generally. Okay. So this part, HV part, this is out of the building. This is not related to us. So this is step down, step up panels will be outside of the our project. Maybe it can be in the road or it's government property, something else. But this part, it's related to buildings. This is called substation. Substation. Which related to project. We can type project substation. Project substation. Okay. So this is the project substation. This is also called substation, but it is different ideas. So for now, we don't need this one. We need here. I hope you understand. So when we are making a substation drawing, this is related to building. This is related to building or the project. This is project. Okay. I will type this one project. Okay. So let's keep this one here, no problem. So this is the substation we are going to play. So substation meaning it's a very big thing. We will go step by step. So this is the network, electrical network, how it will work. Okay, now I am going to draw a row. So you know this one divided into three parts. So let's divide one here, another one here. Okay. So this LV panel, I will draw one here. Okay. So this one we will call LV panel. Wrong. LV. So this is LV panel. So this LV panel, you will have some uh, duct. Mostly this duct is 100 mm. Copy this one, CO 100, 110, and this two mark and C, you will take this diameter. So this one mostly you will have 4 to 6 pipes. Copy. So this one pipe runs below 600 to 800 from ground level. So these pipes will take cable from here. This one coming. So inside the building. So I am using different color. Polyline. It will connect here. So this cable, currently I am working in Qatar. So they have two type of cable. Mostly will come 3 core by 240 or 3 core by 300. It's depend country to country. Okay. So this cable will connect here, and from here we will have transformer. This transformer can be one, can be two, can be three, can be four. It's depend. Okay. As per the project requirement. So I will make three. So here, if you have three panel, they will design the LV panel as per that one. So there will be a connection like this. One, two, three. Okay. So this is can be same cable type. One, two, three. Either 240 or 300. It's a three core cable. Okay. So from here, if you have three transformer, there meaning three LV panel will be here. Sorry, MV panel. Okay. This one connect like this. So this cable can be let's copy one 4 core by 600 or 800. It's depend, but it will come 7 cables. 7 by 4 core 800. Sorry, it's not 4 core, 1 core. Or 10 by single core 800. This can be 600. Sorry, this one 600. Okay, this is the cable. So we will look this cable size correct or not in the designing, because this can be changed project to project. So there will be a cable something like this. Either 10 by 600 or 7 by 800. This is the cable size. Okay. So what do you mean 10? Three red, three yellow, three blue, and one neutral. Or two red, two yellow, two blue, and one neutral. That's why 10 or 7. Okay. From here, the rest. Going to SMDB, the same network can come here. Let's copy this one. I will copy this one here. So I will cut this one, and it will be here. Okay. So this can be many cables. So if I have another one network, so there will be another cable from here. So it can be another one. So it's as per the design, 3, 4, 5 connection can be done. It's as per the design. So this is how substation will work. So here, sometime can be cable, sometime can be bus bar. Bus bar. It's depend on the design. Okay, BUS bar. So this bus bar, same sizes will be, the rating will be as per the required ampere. So how much ampere can be transformer? Normally in Qatar, I am currently working in Qatar. I have used 2000 500 kVA. And there's another one, 1800. This is what I know. Okay. And there is a two type of transformer. One is dry type. Another one is oil type. As per the location, can be changed. Maybe if you are using underground, you have to go with the catalog which type is better for the underground. Meaning, if you are using your substation in the basement panel, you can go with I think dry type. If it is outside, I think you have to check. I forgot this one, but let's check. Dry type transformer. Uh, using place. Normally, dry type. Let's type dry type transformer. Okay. The dry transformer, unlike their liquid field counterpart, dry type transformer do not incorporate liquid. Dry type within dry type located. Let's type located. Dynamo later use specific equals to normally dry type, as I know, it will be below the building. Oil type is external. Okay, which type transformer? Which type transformer suitable in basement area? Which type of transformer suitable in basement area? Okay, so dry type transformer are primarily designed for indoor applications. See this one? This is what I am looking for. So basement inside building, it's better for dry type. If it is external, you have to use oil type. So in external, if I type external, let's type exterior area. Um, oil type, I think. External. So Google not giving a good answer, so I don't have to waste the type. So this, if this dry type for internal, that meaning oil type is external. So this is the way the substation design. So how this cable will run? Normally there will be a touch like this. Okay. If it is bus bar, no need touch. So let's make hatch this one. Let's go with this one. Let's type 100. Okay. Then from here also, same branch. Okay. So let's copy this one. So from here, if this trans will be continue up to here, something like this. Copy up to here. Okay. So from here, there will be a duct, same like this. Then it will go to the building. From the building, they will take through the cable tray. If there's no duct, so it will go to the direct to the electrical riser, and it will go to the building and it will be distributed. So it's a base sketch how transformer look like. So I have a drawing. I will show you. It is in the. Let me open the drawing for you. So E symbol. Okay, AutoCAD symbol installation. I have shared this file. You can take from my video. I have attached the link. So generally, transformer look like this. Now I am going to go for the more deep detail because I don't want to go suddenly deeper, so you will be confused. So this is one of substation drawing what we have that in my previous project. So this you see this one HV room here. You mentioned we have mentioned here HV room. So it's before 20 years before, 10, 15 years before. We used to say this LV room to HV room, MV room, this one, and this one we call this is transformer room, and this is generator room. This one now we call MV room, no LV room, and this is MV room. Okay, so this is they changed the now changing the name. Before you used to call HV room, so don't confuse with this room name. Okay, so we have internal cable, coming cables from here, and coming cable from here. So there will be a panel. As I told you, this LV panel, this one, it will stay here, and through this tranche, you see this tranche, through this tranche, it will come to the transformer, one, two, three transformer. So I will show you the sectional drawing, so you will understand more deeper. So from the transformer, it will come to the panel. You have see one, two, three panel. I have another panel also. I will come to there. So this one will be give uh, it will connect to this panel each transformer. From here, the cable go outside from here, okay, and it will go to the building. So this is government power, electricity we are taking from government, okay. But if you have a generator, this generator, you are seeing this one generator, okay. So this generator, you can pause the video and look very well, so you will understand more deeper. So don't miss this one. So deep look. So this generator, in case of emergency, let's say we have no power here. So this generator will start and give power to this synchronizing panel. So this synchronizing panel seem like this panel, no different. There is a different, but work is similar. So this synchronized panel will give power, take this all generator power to here and give power to these panels. So there is a power from the government supply, there is power from the generator. Okay. So here in this panel there is a one will be there is a one ATS panel called auto transfer switch. Mm, it's not mentioned here. So this auto transfer switch, when government power off go off, it will transfer the switch, meaning like a plug, so, left and right. Example, let's say this one, government. I will draw for you. So this is coming from government, okay? We will make it red. And this is coming from generator. And this is how. When this one power or government have power, it will connect like this. When the government power cut, then it will go like this. So there's a mechanical system here in the ATS panel. If you go to the ATS panel, if you search in the Google ATS panel, wiring diagram, so you will see here how it is transferring uh, the power. You go one by one, you can search. So I don't want to go deeper there. And also there will be one capacitor bank, this one. So this is the total panel and attached with the capacitor bank. Sometimes it is coming with the panel, one panel, sometimes it's not. So how MB panel look like? So you type here MB panel. So this is the MB panel. Okay, see this one. So let's go. This each this one. See this one. This each one, each breaker, and this is control everything. It's included. So you can go deeper when you learn only the MB panel. So this capacitor bank to maintain the current, it will come with each panel should be have capacitor bank. Okay. So this I am talking about the base. Okay, base concept. So we will come to the designing concept. Maybe I will make another video. Okay. So this is the base stick. So you should have one LV panel and then transformer as per the MV panel, how many MV panel you have. As per the transformer can increase. Okay. Then synchronizing panel, if you have generator, more than two generator, three generator, everything connects synchronized panel, it will distribute the power. Okay. So this is a diesel tank for the generator. And this is the breaker. Okay. This generator breaker. So you will know this one generator will go here from here to here. So you can turn off here. So no power here. So this is breaker like a switch. It will work like switch. So if you go here, you see here this one sketch hatches. These are the trench. Okay, let's go to the section. See this one? These are the trench. So normally there will be 1.2 depth and 1.2 width for the MV panel trench. And there was another section for the HV. Normally it will be 1.5 deep. You see here 1.5, and the length will be normally 1 meter. Okay, so you can see here 1.5 and minus 1.5 mm from FFI. Okay, so these are the ducts. See the 2 by 3 nose to 160. So this ducts is various. How many cable going out? It's depend. Okay, so here 1.2, 1.2 depth. Okay, so I hope you understand. So these are the trench. You see this trench to run the cable. If you go, I have another section inside the substation how they run the cable. Let me check for you. I was having one section. Okay, yeah, here it is. Sometime we will put cable train ladder and the cables. Okay, I hope you understand this one. You can post 1 minute and I hope you can read it and you can see this one. This is the arrangement inside this substation, this stretch. Okay. Now in the generator part, we have 2000 kV. Oh, let's go for the substation. How many kV? This transformer is 2000. Let me check. It's 2500, I think. It's not mentioned. TX1. Okay, not mentioned here. Normally, this is 2500, as I remember. Okay. So here we have generated 2000 kV. What is kVA? kVA meaning kilovolt ampere. If you want how many kilowatt it can produce, this generator, you simply multiple this kVA with the power factor. Okay, then you will have watts. So if power factor is zero point 0.9, calculator, if power factor is zero point 0.9, that means 2000 into zero point 0.9. So I can get 1800 kilovolt watts, meaning kW. Okay, this one can produce 1800. So I have 3200 ampere. So this 1800 multiplied by 1.754, 3157 ampere. This is a thumb rule. So they have 3200. Okay. So it's enough breaker. They put for the maximum. This actually 1800 minutes included some spare also. So they have this one. So thumb rule 1.54 also we use. It's depend 1.75. It's depend on the power factor. It can be changed. And if you don't understand, you can go for my other video. Check my old video. You can learn how to take ampere everything. So if you see here, this is the main thing. Okay, this is sound or attenuator. So this one will be generator supplier. They will design this one to reduce the sound. And also there is a should be a fresh air intake and air out also. So it's not mentioned here. Okay. So here we have something which come with the generator. You see here this mark for the air. So there will be lower. See this one. Fresh air lower intake. See this one. And this is sound alternator. So it's included with this one. So this is in and this is out. Okay, you see this one showing this symbol out. So it's they connected with the generator. So it's depend on the design. Okay, and so there is a fresh air in, fresh air out. Sorry, fresh air intake and air out. This is very important. When you are designing a generator room, you have to consider this one also. Okay, so you should know what fresh air in, fresh air out. What is the AC? Why ACB? There is certain amount of ampere increase. I think 600. It will be ACB. So if you go ACB, it will be start with 600. Air circuit breaker, air circuit breaker. Start. Rating and ampere. So we'll go ahead. So air circuit breaker. So normally start from 600 ampere. Starting amperage. We will type amperage. Ampere. Here chart. Okay. Let's go with the chart. Let's go with the image. So circuit breaker size, copper wire size. So these are the circuit breakers. So air circuit breakers, normally if you have more than 600, you need to use air circuit breaker. So I think there's no proper information here. So you can check in the Kaharma book. You can download Kaharma standard. If you are working in the Qatar, Kaharma standards, you can download the PDF and look at here. Let's right click. Okay, let's find here. Control F, ACB. Yeah, circuit breaker. This is the air circuit breaker. So we will go next. So here, where MDB is connected directly to the low voltage winding transformer with any immediate cutoff, the main controlling switch shall be okay. There's no I mentioned the breaker size. Okay, current rating above 630 ampere should be of air circuit breaker. This is standard of Qatar. So I don't know what about the other country because I'm currently working in the Qatar. Their standard is above 630. Should be ACB. So how much we have here? 3200. So it will be ACB. Okay. Okay. Then the transformer also we can see here. Transformer. Okay. The total height, depth, everything you have mentioned. This is the front panel. So let's go with this one. Okay. Transformer. Alaikum salam wa rahmatullahi wa barakatuh. So you can check from this table around about transformer, uh, transformer amperage.
Yes, at least I have one seat,
So this one, you need another one you want to focus.
which is
You have to consider this spacing. So this panel, first you have to know the front panel, you have to mention. So there is a certain rules, the panel back, front, and left and right. So if you go to the Kaharma regulation, let's go to the Kaharma regulation. Let's make MB panel. So here, so it's depend, some area we have to give 600, some area we have to 800. Spacing. So let's do panel. Okay. Mm, You can check in the Kaharma regulations. So this is also regulations. You can check the transformer incoming top bus duct should be 2500 amperes and the generator incoming bottom cable 1000 mm total with outgoing bottom cable. There's certain rules are here. So if you go down here, I think let's go here. Panel. So we go more. Okay. This is also some other standard. So you have to search this country to country. It can be different. So if you go to the search panel, See this one here. They mentioned the axle not less than 750 mm wide and 2000 meter high. So where's the switchboard? Actually, we have to go with the switchboard. Then we will know. Okay. Then second, see this is the standard. You can check this one also. Anyhow, if you want to design or understand the substation, you have to read this one everything. Because I don't want to just say by word and without any proper document. So here you see this is the minimum size of this earth bar should be 300. This is related to earth bar. So we will go gland. Okay, that meaning the previous one is better. We can find LB. No, panel. So this is required clearance. You have to read this one. Ah, here. This is the one. So minimum 1.5 meter front clearance. So front of the panel you have to keep 1.5 meter and rear 750, side 750 and panel to panel between 750 and this clearance of ventilation around capacitor back 750 meter. 750 mm, that means 0.7 meter. So everything 750 consider and front clearance 1.5. So if you go to Dubai, another country, it can be different and other country also different. So everything you related to substation you can find here. So in general, I will make another video more deeper. This is base, very base thing I am telling. And then the another video I will make so calculation, cable selection, panel selection, transformer selection, generator selection, single line diagram, everything. Because I don't want to put everything suddenly one time, so you will be confused. And I don't want to make a long video, it will be boring. So for now, for the time being, uh, check this video 2, 3 times. So inshallah, another video I will make the more other details. After now, check the video, learn it. So until next video, we will meet inshallah in next video. Until next video, take care. Goodbye. Assalamu alaikum.